Hey everybody, and welcome to my 2022 finale. Um, Last year I did an infinite sum, so it only follows that this year we do an infinite product. Um, this time I think I know what I'm doing, so I won't say anything stupid, hopefully. Um, so yeah, let's get started. We have, I guess the product, some people call it pi notation. I'm just going to say the product as n goes from 1 to infinity, the same way I would say the sum as n goes from 1 to infinity. So we have the product as n goes from 1 to infinity of e to the 1 over 10 to the n times 2 to the 1 over n squared. Now, I'm not super familiar with infinite products, but there's a property essentially saying that because it is a product, if we took the natural log of this, so we take, I'm using black. Hold on, give me a second. Oh my god, that's the wrong brush. What brush am I? Oh, here. So we would take the natural log on both sides, or rather, natural log of this product, ln of this infinite product. Well, what do we know about natural logs? We know that the product of a natural log, or rather, if there's a product inside the natural log, it is the same as the sum of those two natural logs, which if this is infinite, we can then represent that as an infinite sum. So that's what we're going to do. This is the same as sum as n goes from 1 to infinity of ln of now this inside. So we would have e, the 1 over 10 to the n, multiplied by 2 to the 1 over n squared. Now, further with the whole properties I'm abusing here, we have natural log properties. We can split this up into the sum of two ln's. So, and furthermore, beyond splitting up the sum into two ln's, when we have two things adding in the sum, we can just split them off into two separate sums. So that's what we're going to do here. I would then have sum as n goes from 1 to infinity of ln of e to the 1 over 10 to the n plus another infinite sum as n also goes from 1 to infinity. I could use a different variable, but it's whatever, of ln of 2 to the 1 over n squared. Now, some of you, especially keen-eyed viewers or people who are just better than math than I am, will notice that this is actually really easy to solve. For our first sum here, we have ln and e, these cancel out, and it becomes just a geometric series that's really easy to solve. It would be the sum, so n goes from 1 to infinity, of just 1 over 10 to the n, which by the whole geometric series formula, we would literally just get 0.1 repeating. That's really easy. And as for the second one, this one's also really easy because by another log property, we can bring the power out front. So we would have 1 over n squared times ln of 2. ln of 2 in this case is just a constant. We bring that out front. So we would have ln 2 times our infinite sum. So n goes from 1 to infinity. It's a bad infinity. Wouldn't be a math video without me making awful handwriting decisions, of just 1 over n squared, which is just the Basel problem, and my guy Euler from, way back in the day, he's already solved this. This is just pi squared over 6. I'm not going to do a proof on that because I'm not smart enough. Pi squared over 6 times, of course, ln of 2, which is still out front. So all in all, if we take the sum of these two, we would get back our original sum here. So I just have to add 0.1 repeating. Now, we could just say this is what our infinite product equals, but this is what the natural log of our infinite product equals, because I took ln out front to be able to do all this computation out. This isn't actually our infinite product. This is, like I said, the natural log of it. So what we actually have to do to cancel out this natural log is we have to raise or exponentiate both sides by e. But this is not a particularly nice expression to exponentiate. I could put e out here and we'd have e to the pi squared over 6 times ln of 2 plus 0.1 repeating, which isn't particularly nice. not any real values. This is like actually the exact answer, but I want, just for the sake of it, to get a decimal approximation. So what is pi squared over 6? It's about 1.64-ish, but if we multiply that by ln of 2, I'm going to do that over here. Just put this into a calculator. But we got 1 point. It's a long number. Is that what it is? It is. Okay. 1, 4, 0, 1, 8, 1, 4, 1, 1. So that's pi squared over 6 times ln of 2. Of course, we add that to 0.1 repeating. We just add 0.1 to all of those. 0.1 repeating. We get out approximately 1.21. Is that? Oh no. Wrong order. 4 plus 1 is not 1. 5. It's a bad 5, but whatever. 1, 2, 9, 2, 5, 2, 2. So this is what we're raising, or exponentiating by, so then we would have e to this power, 1.25129522, or 2522, which ultimately spits out at us the ol' super nice and concise number. I'm going to write it down here because it's kind of long. We get about 3.498572118. And this is what our infinite product actually equals. So if we call our infinite product p, p is about equal to this. Now there's some other stuff we could do with infinite products, and I specifically designed it to be this way because there's this whole thing with diverging to 0 and whatnot, and it's not super fun for me to deal with because I'm not smart enough. So anyway, let's go to Wolfram Alpha and see what they say. That is to say, I'm hopefully right. All math inputs, and we do n equals 1 to infinity. And then, how did I do it this last time? I really hope I input this correctly. That's a 19. Already wrong. No. Right here. Okay, there we go. And then we multiply by not e2, 1 over n squared. Let's hope I input this correctly and the computer actually knows what I'm trying to say. Oh. Well, it wouldn't be a math video if I didn't get something wrong. Promise you guys. I promise it's not 0. The answer is not 0. This video would be pointless if it was. Dude, I input it wrong. I did in fact input it wrong. Hold on, okay. I am wasting everybody's time. I do not care. It is New Year's Eve. This was supposed to be fun. How do you input this thing? We'll try one more time. How do you input this? I forgot. I did it once and then I forgot. Let's do this. Are you sure I can't just have it? Like, I guess not. Huh. Maybe it's... Maybe we'll do that. Maybe that'll solve our problems. If not, I'm just gonna pull up my history. Oh no, my search history. If this doesn't work, I'm just pulling up my search history. Please work. It did not work. It gave me the same input as last time. Okay, this one right here. Wait, I just opened the tab I already... Okay. Where is it? This one. Please tell me it's this one. This is not this one. Which one of my where is it? I'm gonna open all these. These are all too recent. No, these are all wrong. How do you... Dude. Okay. Well, so much for showing Wolfram Alpha telling me I'm correct. I promise you guys, I am actually right this time. You could put this into a calculator. Maybe I don't know, link a screenshot of it later or something, but P, our infinite product here, does in fact approximately equal this. If you figure out how to put it into Wolfram Alpha, please let me know. I'm not very good at using it. So yeah, happy New Year's, I guess. It's 9:12 p.m., so we still got 2 hours 48 minutes, but you know, when this goes live, it'll probably be closer to New Year's if you end up watching this. So yeah, it's been a fun year. Made a lot of mistakes. Made a lot of mistakes in my math videos, but it's been a fun year. So yeah, thank you for watching.